Okay, we've all been there, right? You've been coding away, you feel great, you hit run, and wham, it all just comes crashing down. You're left staring at this cryptic error message, just wondering, where did I go wrong? Well, today we are putting on our detective hats. We're going to dive into a crash script and solve this case together.
And here it is, our first clue. This is the message our program left for us right before it gave up. Now I know, it might look like a bunch of technical gibberish, but this one single line is the key to solving our entire mystery. It's telling us exactly what went wrong, we just need to learn how to speak its language.
So, what is our script trying to tell us? You should think of errors less like roadblocks and more like messages. The script is basically waving a little flag saying, hey, I'm really confused about what you just asked me to do. Our job is to translate that message and, fix the miscommunication.
To solve this mystery, just like any good detective, we need to examine the crime scene. We got to gather our evidence. And lucky for us, we have 3 key pieces of information that are going to help us piece together exactly what happened here.
So, on our evidence board, we have 3 key items. First up, the error log.txt. Think of this as our only witness statement. Then we have main.py, that's the scene of the crime itself, and finally, our list of potential accomplices, requirements.txt, which lists any external libraries that might be involved. Were they in on it? We're about to find out.
Let's start with our most important piece of evidence, the error log. This is where the whole story of the crash is written down, from start to finish. Our first job is to read it carefully and pull out those vital clues.
Okay, so when you open up that file, you're going to see something called a traceback. And yeah, I know, it can look like this big, scary wall of text, but trust me, it's not. Think of it as a roadmap that literally traces the program's steps right up to the exact moment of the crash. We just need to know how to read it.
And here's the secret, the #1 rule. Always read a traceback from the bottom up. The very last line tells you the what, the specific error, which in our case is a type error. Then, as you move up, you find the where, the file name, main.py, and the pinpoint accurate line number, line 7. See? Not so scary when you've got the map, right?
So, what even is a type error? Well, it's pretty much what it sounds like. It's Python telling us we've mixed up our data types. It's like trying to add the number 5 to the word apple. It just doesn't make any sense computationally, right? You can't add a quantity to a concept. Python gets just as confused by that as we would be.
All right, we are armed with our clues. We know we have a type error, and we know it's on line 7. It's time to visit the scene of the crime. Let's open up our main.py file and see exactly what's happening on that line.
And here's our code. It's a pretty simple script, really. It just defines the user's name, their ID, and then it tries to create a little welcome message. Our trusty guide, the traceback, has flagged line 7 as the source of all our problems. So let's zoom in on that line. Now, at first glance, this sign looks perfectly fine, doesn't it? We're just using the plus sign to join, or, as the pros say, concatenate a few strings together to make a nice message. The code looks right, but our type error clue tells us there's a problem hiding in plain sight. So, where is it? Okay, so we're joining some pieces of text and our variables. We know the text parts, like ID is, are strings, and the error isn't complaining about user score name. That really only leaves one prime suspect. Which variable here isn't playing by the rules? And there's our culprit, red-handed. The user name variable is a string, just plain text. But look at user ID. It's an integer, a number. That's the data type mismatch our type error was yelling about. So here's the crucial aha moment. In Python, the plus sign is kind of a multitasker. It's smart enough to add numbers together, and it's smart enough to join strings together. But what it can't do, what it's not built for, is mixing and matching. It sees the string ID is and the number 1, 2, 3, 4, 5, and it just throws its hands up and says, whoa, I don't know how to combine these. And that's when it gives us that type error. But you know what the best part is? Now that we've done the detective work and we've found the exact cause, the fix is unbelievably simple. We don't have to rewrite the whole program. We just need to make one tiny little change.
So on the left, you see our problem code. And on the right, the super simple fix. I mean, look closely. The only thing we've done is wrap our user ID variable inside string. That's it. That one tiny change makes all the difference in the world.
So what does string actually do? It's really simple. It takes whatever you put inside the parentheses and it just turns it into a string. So we're basically telling Python, hey, Just for this one operation, please pretend the number 12,345 is actually the text 12,345. And now, the plus sign only sees strings, it happily joins them all together, and our program can finally run without a single complaint.
And just like that, case closed. But the real goal here isn't just to fix one bug. It's to learn a method we can use to solve any bug. So let's recap the key principles we used and turn them into a handy guide for your next debugging adventure.
All right, let's add these tools to your debugging handbook. Number 1, trust the traceback. It's your best clue, always. 2, read it from the bottom up. That's where the good stuff is. 3, identify the error type and the exact line number. 4, check the data types of your variables on that line. And finally, when in doubt, just make your data types match.
And that's really how you crack a Python type error. This exact same detective method, read the traceback, find the line, check your data, it works for all sorts of other cases, from a name error to an index error. The key is to stop thinking of errors as roadblocks and start seeing them as puzzles. They're just clues that lead you to a better, stronger script. Happy debugging!